Welcome back, everyone. In this video, we're going to continue by working on some examples of solving linear equations, starting with this one. First of all, in this one, you'll notice that the left side, there's a set of parentheses and also a set of square brackets. When you see equations like this, there's no separate meaning for the square brackets. It's just that if we wrote every level using only parentheses, it would be hard to read. Many people feel like alternating between brackets and parentheses makes it easier to read. So that's all there is. The second thing is there's some personal choice in here on how we may want to proceed. Some people would like to simplify the inside first. Some people would like to begin by distributing the 10. And you can go either way with it. Either way is okay. I'm going to do the first one. We'll simplify the inside first as much as possible. So let me distribute this -8. Okay, so -8 times 2x is -16x, and then -8 times 5, that's +40. And that's all we can do on the left side for now. The right side, we're going to distribute the 15. 15 times 40, 15 times 4 is 60, plus the other 0 makes 600. And then we'll have 15 times 5x, that's 75x. Okay, and then continuing onward, the left-hand side, we can combine like terms. We'll have 10, and then we'll have 43 minus 16x. And then the right side, nothing happens. Distribute the 10. We'll have 430 minus 160x. Then the right side, 600 minus 75x. Okay, so here we can collect the variables to either the left side or the right side. Either way is okay. Most people like to have a positive coefficient, and so most people will choose to add the 160x to both sides. But if you wish, add the 75x to both sides. Using the addition property, either one is okay. You're just going to have different looking work. Okay, so we're going to add the 160x to both sides. Okay, so then on the left side, of course, we'll just be left with 430. And then on the right side, 160x minus 75x will be 95x. Okay, and then let's subtract the 600 from both sides. This looks like a lot of writing, and if you're comfortable with skipping steps, that's okay. I find including more steps make it so that I make fewer mistakes. Okay, 430 minus 600 is going to be -170. On the right side, the 600 and -600 add up to 0. We'll have 95x. And then dividing both sides by that 95, we're going to end up with just our x on the right side. -170 divided by 95 will be -2. And so our solution there is -2. Okay, so remember, if you took some different steps, you could achieve the same answer with just a different looking work. One other way that we could have proceeded from the beginning was you'll notice that there's a coefficient of 10 and a coefficient of 15, which are both divisible by 5. If we had so chosen, we could have begun by dividing by 5. So let me show you at least how the beginning steps would have worked. I didn't do it that way because the way that I'd presented the rules for this more or less was to distribute and work on each side separately first. But if we wished, left and right side both divisible by 5. So let me divide 10 by 5, giving 2. 15 divided by 5 will give 3. Then our next step will look like 2, 3 minus 8, 2x minus 5. Let me make that a bracket again. An advantage to doing it this way is that the numbers you're working with are smaller. The arithmetic is then going to be easier. So let me show just a couple more steps. Of course, if you don't like it, you can skip ahead. Okay, so the working with the inner parts of that left-hand side are the same. Okay, all right, so there's that. So this will finish in the same way, but you can see it's because we divided out those fives that the numbers are going to end up smaller. Okay. Our next kind of subtopic here is to look at how you can classify linear equations in one variable according to the number of solutions they have. And there are three terms that we use to describe this. First of all, a conditional equation is an equation that's true conditionally. Sometimes, right? Sometimes yes, sometimes no, and it depends on what the value of the variable is. An identity is true always. It's true for every value of the variable. A contradiction is true for no values of the variable. So let's look at some examples. So we're going to start with 2x minus 1 equals 11. I think all of us here are going to add 1 to both sides first, and then divide through by 2. So we'll get 6. 6 is our solution, and this makes this a conditional equation. What's conditional about it is that this equation will be true if you replace the x by a 6, and it will be false if you replace the x by anything else. So it's a conditional equation. Okay, 3x plus 4 equals 3x minus 1. I think we would all subtract 3x from both sides. If you do that, you're going to get 4x equals negative 1. That's, of course, false. That makes this a contradiction. Okay, when you have a contradiction, that means that there's no solution. And how you can express that is by writing out the words no solution. You can write curly braces with nothing in them, or there's a symbol for the empty set, which looks like a kind of a fat zero with a slash through it. All of those mean that there's no solution. Okay, here's one where we can distribute to remove parentheses first. And then if you look at that, you're probably already suspicious about it. We've got 2x minus 13 equals 2x minus 13. And of course, everything is equal to its own self. And so it looks like this one will be an identity. If you don't see that right now, that's okay. You can continue with more steps. Let's add 13 to both sides, and then maybe subtract 2x from both sides, and you'll end up with 0 equals 0. And that's always true. There's not even a variable in there anymore. So that is an example of an identity. Okay, so to sum up, we have some words for describing how many solutions a linear equation has. Conditionally, if it has one and only one solution. Contradiction, there's no solution. Identity, infinitely many solutions. Here, by the way, I've stated this in this context about equations in one variable. If we're working on other kinds of equations, then the kind of definition for conditional is slightly different. But for now, this will work for us. Okay, 2 more equations for us to solve. In this first one, again, we're going to be distributing to remove parentheses first. So let me do that. So we'll have 12x plus 5, 12x plus 25 rather, and then 15x. As a reminder, feel free to stop the video, try the steps yourself, and then restart the video to see how you've done. We have 3 times 9x is 27x, and then minus a 12 in the back. Okay, so we will have 27x plus 25 is equal to 27x minus 12. Okay, let's subtract that 27x from both sides. We'll have 25 equals negative 12. Okay, and that's always worrisome, right? When something like that happens, it means one of two things. Either I made a mistake, and I don't think I have, or there's no solution. So there's no solution here. Okay, we can write out that set of empty curly braces. Okay, let's try again. Maybe this one will be more fun. We have 6 plus 14 times k minus 8 equals 95. So distribute first. 6 plus 14k minus 48. Not 48, that's not 48. That's 112. Okay, so then combining our two constants on the left side, 6 and negative 12, that will give us negative 106. Okay, so we're going to add 106 to both sides. Okay, and then the left side, of course, that leaves us with 14k, which was the plan. And then on the right side, this should give us 201. Okay, and then dividing through by the 14, we'll have 201 divided by 14. Okay, and so let's check and see if that simplifies any. I don't see any common factors. 14 is 3 times 7. Sorry, 2 times 7. 201 isn't divisible by 2, and I don't think it's divisible by 7 either, but let's divide to find out. 201 divided by 14, that will go 1. There's 1 and 1. So it looks like it doesn't simplify any further. In algebra, we typically are not going to leave that would be 0. We're not going to leave mixed number answers. So this would be like 10 and 11, 14. And so we're going to leave it just as an improper fraction, 201 over 14 for that. Okay, all right, so that takes us to the end of this second part on solving linear equations in one variable. In the next part, we'll see how do you deal with it if there are equations in that contain fractions or equations that contain decimals. So that's what we'll take up next time. In the meantime, let me know if you have any questions